physical and for the chemical. Then, in conclusion, this Congomania latitudinal fiber possesses a favorable properties for eco-friendly engineering application, particularly in composites. The chemical and the physical properties analyzed in this study indicate a high potential for renewable energy and its use. Further research can optimize fiber, improve this fiber improve performance, contributing to sustainable material development.
Thank
Thank you
you.
for your
Please,
attention.
a round of applause for the presenter. Over to the chair.
Thank you so much for your presentation. Any question, please? Do you have any question? We have one person to ask a question. Thank you.
Presenter, thank you very much for that wonderful presentation. I want to ask a little question to have an understanding of your field of study. You mentioned bulk density is low, which is expected, so that when you add them to materials, it won't be too heavy. Please, can you help me analyze other things you measured in line with the reinforcement material, such as ash content, moisture content, cellulose content? How do you tie it to the effect on the reinforcing material? How does those factors affect the material you are reinforcing, the results you got? Can you help me understand them?
Over to you, presenter.
If I heard you correctly, you are saying about the ash content.
The value you got for the ash content, the moisture content, and the cellulose content. How do you explain those values and their effect on the material you are trying to reinforce? At least I understand that for bulk density, the value you got is low, so it helps whatever material you are reinforcing not to be so heavy. So how does the value you got for moisture content, ash content, cellulose content, what do they contribute to the material you are reinforcing? Those values you got, how do they affect the material you are trying to reinforce when you are considering
Okay,
that gongronela?
like in my presentation, I said the moisture content we obtained a value of 1.71. This moisture content indicates effectiveness drying and suitability for the humid environment. Why the ash content reflects significantly in the mineral content that may enhance thermal stability. Then the bulk density, when we obtain a 0.4 gram per milliliter, suggesting the characteristic beneficial to the handling of and transport.
Okay, if you can make it more clearer in another 2 minutes, that will do. Okay, for want of time, a hand of applause for the presenter. Yes. So please, we await the presenter of paper A6. A6. Paper A6. Paper A6 is also online.
Can you hear me now? Okay, thank you. Good evening, everyone. The paper I'm presenting is all about prediction of compressive and flexural strength of concrete containing Bambara nutshell ash and quarry dust as partial replacement of cement and sand dust using artificial neural network. Well, we all know that the cement, please go to the introduction, please. We all know that cement is one of the most expensive components that we use in making concrete in the country. And part of the reason why I use Bambara nutshell, it's part of the reason why I use Bambara nutshell and quarry dust as as an alternative binding material. The Bambara nutshell is to partially replace the cement, while the quarry dust is to partially replace the quarry dust. Basically, when we go to the lab to make concrete, we use trial mixes, and this is time consuming and it is always expensive and time consuming. There is need for us to look into this building industry to look for alternative material that can partially replace cement to some extent. Bambara nutshell is one of those materials, and quarry dust too. It can serve as a replacement of sand in our concrete. The significance of this study shows that we need to adopt a cost-effective and eco-friendly available material. We cannot continue to spend so much on cement while we waste food material, while we waste agricultural products that can be used in concrete. Bambara nutshell is gotten from okpa, the popular okpa that we eat all over the southeast. Bambara nutshell is the shell that we got from it. This work is a plus to the agro waste management because it's going to reduce open burning of this our food waste. We can use all these food waste such as Bambara nutshell in making concrete. There have been so many reviews that have been done on Bambara nutshell. The literature, there are so many authors like Awodiji and others, Nwa David et al. And others like that. They have made a lot of findings, and the limitation of their work is clearly stated in this slide. Many of these works does not make use of artificial neural network. Three methods were considered in this experiment: the experimental, the prediction, and the statistical. The prediction and the statistical are what was stressed in this particular presentation. I carried out the experimental work in the laboratory, and the result is subjected to the artificial neural network toolbox to generate results for our prediction. The binder and fine aggregate were the Barbara nutshell and the quarry dust. So there are some gaps in the previous studies because the distinctiveness of this study lies in its input and output architecture. In most of the studies that have been done in the past, we discover that we have two or three components in making our concrete. This particular work actually made use of six inputs and generated two outputs. The content of its layer is also such that has not been addressed in the preceding work. The research findings of this work shows that it shows us the unique application of artificial neural network and is justified for its efficiency in data processing and model reliability. This study also acknowledges the importance of flexural strength, especially in elements subjected to bending and tension. Why do I have to use artificial neural network? ANN has gained more attention than other statistical models because of its ease, speed of predictions, and ability to obtain the optimal material combination. The choice is also justified based on its ability to handle complex relationships and its capability to work with incomplete knowledge and others. Then, the materials used are cement, Bambara nutshell, aggregate, quarry dust, And the experimental tests that were carried out include the physicochemical analysis, the sieve analysis of the aggregate, the compressive strength, and the flexural strength. The diagram on the screen shows the model of the ANN, which shows us the 6 inputs that goes on into the predictive model and the 2 output layers. The result of the physicochemical properties of the experiment is displayed, while the result of the compressive, the flexural, and the ANN result were all presented. If we look at the comparison of the elemental result of both the neural network prediction and the compressive strength, we discover that the percentage error is 2.44%, and this is less than 10%, which is the minimum that we should get. 2.44 is what we get instead of 10%. In conclusion, increasing the curing age resulted in increased flexural and compressive strength when we use Bambara nutshell and quarry dust, but beyond 23% replacement. The workability increased with increase in replacement of cement with BNSA. Then the partial replacement of ordinary Portland cement with Bambara nutshell reduces the concrete member weight due to its Bambara nutshell lower specific gravity compared to cement. This research validates the potential of Bambara nutshell and quarry dust as a sustainable cementitious material. Industry professionals can leverage on this model for efficient mix optimization. What are the contributions to knowledge? This study proved that ANN is suitable and reliable interface for modeling the compressive and flexural strength of concrete. The results and analytical details derived from this experimental investigation will also aid the utilization of agricultural and industrial waste. So beyond 23% of OPC and sand with Bambara nutshell and quarry dust, the concrete is not suitable for construction of heavyweight structure. Recommendations. The following recommendations are made based on the result of this work. The model is suitable and adequate for optimization of strength properties of Bambara nutshell and quarry dust. And more studies should be done on the use of neural network to predict other properties of Bambara nutshell, ash, and quarry dust. So the era of when engineers get to site and we are having difficulty of choosing the mix ratio is over. With artificial neural network, we can actually optimize and get the mix ratio that we can easily use on site. This will save us a lot of time, it will save us a lot of stress, and it also helps us to make use of agricultural waste that normally we would have thrown away. In Enugu State, there is a large consumption of Awka. The same thing in the north. They consume a lot of Bambara nutshell, and the shell actually is of premium value that we can use in making concrete. The same thing with our quarry dust. There are some areas where sand mining has been banned or they are restricted. So instead of people mining sand, they can easily resort to using quarry dust in their concrete production. So partially replacing cement and sand in our concrete using Bambara nutshell and quarry dust will save us a lot of resources and money. Thank you.
A round of applause for presenter paper A6. Please, any questions?
Thank you, our presenter. Bambara nutshell to replace cement and quarry dust to replace sand. Thank you, because you've also made us to know one of the limitations, which is for night, it should not be used for heavy construction. Any question?
My own question lies on the availability of Bambara nut. Knowing fully well that nowadays one cannot do without cement in the construction industry. I don't know if you take into consideration the availability of the Bambara trees in various parts of the country to ensure that they supply the shells to the industries. So I don't know what you considered to maybe how that can be achieved by planting more Bambara trees. I know that in the east it doesn't grow here. We only consume the Awka, and it's being planted or grow somewhere else up north or even outside Nigeria. So I don't know how you are going to achieve that.
Our presenter, please, could you answer that?
Okay, ma. The availability of the Bambara nutshell is not a problem in the east here, where, like I said, when we talk about Bambara nutshell, we call it Awka here. But in the north, they use it to feed animals. They use it to feed poultry. They use it in many areas. So we have a larger quantity of it, and of course it's not everybody that is going to go into renewable energy in their concrete production. So for those that want to go into it, it's a very good place for them to start. So with time, we are going to have a large, the moment others see that, oh, we can actually use this shell, and we are getting results, many people will go into it. For now, the use of Bambara nutshell is not much. So the issue of the quantity of Bambara nutshell that we can get is still manageable for now.
Thank you very much. Another question.
Thank you, Mr. Presenter. Please, my question will buttress on, we know that in mixing of concrete, the cement, the sand, and the aggregate, they have a particular percentage of mixture to achieve a particular stability. So I don't know whether this your research also factors the use of the Bambara nutshell and the dust, whether they also, they are constituted in the same percentage, just as it would do when we are using the normal cement, sand, and aggregate mixture. Thank you.
Presenter, please.
Okay, the replacement is at 2.5% interval. So they are not the same. We vary the quantity of Bambara nutshell. At the same time, we vary the quantity of the quarry dust. So it will get to a time when we are going to have equal ratio, and it doesn't mean that at that point we are going to get the optimal value. So I actually varied the ratio. So it's not as if we are using the same ratio for everything at the same time. The ratio is at 2.5% if we go through the full paper.
Okay, thank you. There's something I want to ask, because this area is very innovative, and everybody's looking for alternative to existing structures. Now, I want to ask, because you talked about your results having a 23% contribution of cement with respect to the Bambara nutshell. So what are the parameters you used to determine the proportion of these materials? That is number one. Then number two, how do you determine the percentage replacement for the crushing strength? Because when you must have done this, then you will have to crush them. In crushing them, that's where you determine the strength of these compositions. Thank you.
I got the first question. You said the parameters used in getting the ratio, isn't it?
Yes.
Okay. Of course, I have the Can I talk now?
Yes, please go on.
I have the control, which is 100% concrete. So from that 100% concrete and 100% quarry dust, I vary the percentage ratio, the percentage replacement by 2.5%. So when the cement is reduced, the Bambara nutshell is increased. When the quarry dust is reduced, when the fine sand is reduced, the quarry dust is also increased. That is how I vary it from 100%.
Okay, thank you. But the percentage sounds vague. So we want a situation whereby it can be characterized in literal things that a layman can understand, if it's cups, if it's painter, if it's bucket, so that we can actually know what calibration it is. But thank you so much. Please, a round of applause for the presenter. Also coming to present is presenter paper A5. That is in the person of Dr. Anyonovo. Please, a round of applause as he comes for his presentation. Please, media, do we still have anybody that wants to present online? Are there still presenters online? Before we take the people that are on site. Any other presenter online?
No other person online.
Okay, thank you, sir. Okay, please, quickly, Dr. Anyonovo, you can make your presentation.
Good afternoon, everyone. Okay, my name is Dr. Anyonovo Ugochukwu from Electrical Engineering Department. I'm here to present the paper titled Innovative Mini-Sun Technology, an Alternative Utility Power Generating Plant. Okay, it's quite unfortunate that I won't be able to project it on the screen, but I'll try my best to deliver the knowledge home. So, in the world of sustainable energy, which our subtopic captured, the engineers are working hard in order to develop alternative source of energy, because the conventional source of energy we have at the moment have a lot of challenges, one of which being the depleting nature of it and the atmospheric hazard that it causes as a result of increase in CO2 gas, which causes ozone layer depletion. So in the course of looking for an alternative way to generate energy, a clean source of energy, scientists has tried to explore, engineers has tried to explore solar energy in different forms. One of the one that is most conversant is the photovoltaic method, which we use the solar panel, and the photothermal process, when you use the parabolic mirror to concentrate the sun rays to a heating chamber. So, but still, we have not been able to arrive at a fully sustainable energy from this sun, capable of carrying high capacity loads when compared to fossil fuel generation. So that research continued. It made engineers to begin to look at a way of extracting energy from the sun in a different form. So one of these came from the idea of fusion technology. Fusion technology is more or less like a nuclear energy sources of energy. And nuclear sources of energy is one of the renewable sources of energy. But the conventional nuclear sources of energy we know, which is the nuclear fission, has a lot of radioactive problem, and is one of the reason why, is one of the reason why it has not, it can generate energy at large quantity actually, but the waste, the management of the waste is another big problem. So they now begin to consider nuclear fission, okay? In trying to do to produce energy or electrical energy through nuclear fission, they studied, or they came across what is called mini sun, or what I call it a means of trying to generate energy from atom by combining them together instead of splitting them together. That's the nuclear fission. So that's in trying to tackle this problem. In trying to tackle this problem, they came out, researchers across board has developed, including China. China developed a reactor called tokamak. And that reactor, the principle of its operation, let me just move fast. This is a structure of the tokamak reactor developed by the Chinese research agency in trying to extract energy from nuclear fusion, not fission anymore. So, and this process simply involves using a high plasma energy to bombard atom of deuterium, okay? And in the process of doing that, when they try to collide with each other, they release energy. Now, the energy that is released is extracted through a stream of, through a network of stream flow, that is water flows. So by the time the pressurized water passes through the heated chamber, it extracts the heat from that reaction chamber and transfers it to the normal steam exchange unit of power generating plant, which can now be used to drive a turbine to generate electricity. Okay. Now, the nuclear fission reactors are divided into different categories based on what is called magnetic containment. What they mean by magnetic containment or plasma containment is that when these atomic molecules are being combined together at a high temperature and pressure, they get melted. And when they get melted, it now becomes a problem holding them in position. Okay, so that process now led them to develop a system called magnetic confinement. This process involves them using a high field electromagnetic field, okay, to hold the molten particle into suspension, preventing it from touching the body of the reactor. That way, the material degradation is reduced. Then the other form is the inertial containment. Inertial containment had to do with using high laser jet to push the atomic particles, let's say deuterium and lithium particles, to the reaction chamber, like by virtue of pressure pushing the atomic particles into the reaction chamber, they are suspended. Okay, that's by virtue of the inertial confinement. Then the magnetic inertial fusion is the combination of the two, while the hybrid fusion takes care of an advanced neutron technology that is, proposed in this research article. In this research article, having gone through the already existing system of trying to combine two atoms together to generate energy from them, the problem of that magnetic containment still remains an issue. That is why in one of the experiments that most of the experiments that are being conducted, including the one that China conducted, Korea conducted, they were able to contain the molten component to just a certain frame of time. One was 101 seconds, the other one was 20 seconds, the other one was 40 seconds before the reactor get melted, and then they had to shut the system down. Okay, so in this, we suggested an innovative structure of this nature, which is more or less like an advanced method of the already existing system, whereby instead of superheating the molten component and